Welcome to my YouTube channel. Today we will start with linear differential equation with variable coefficient. In our last videos we have done linear differential equation with constant coefficients. Now we will do linear differential equation with variable coefficient. What is the meaning of this? If they are saying linear differential equation with variable coefficient, it simple means that in last we have p naught, p1, p2 up to so on pn. These all values are constant. But now in this case, these are the functions of x, means they are in terms of x, means they are variables. So that is known as linear differential equation with variable coefficient. And if there is two type of equation, first is Cauchy's linear equation, second is Legendre's linear equation. So if we have a Cauchy linear equation, means we have a xn d raised to power n dxn, then xn minus 1 up to so on. In this case, p naught, p1, p2, pn, up, these are all constant, and qx may be a 0, maybe a constant, maybe a function of x, anything is possible. So that is known as Cauchy linear differential equation. Now see how we can solve this. So firstly, first step, what we will do here, we will put x equals to e raised to power z, and z can be taken as log of x. Then second step is we will put dy dz equal to theta, and on the behalf of this we will put x d is theta, x square d square is theta into theta minus 1. If we have x cube d cube, we will put here theta, theta minus 1, theta minus 2. Similarly, if we have x4 d4, we will put here theta, theta minus 1, theta minus 2, and theta minus 3. Then x raised to power n, d raised to power n, again we will go up to n minus 1. Next step, we will put all these values in an equation. After putting this equation, we will simplify this equation. Then we will get a linear equation in a constant coefficient. Then we will solve as we have done our linear differential equation with constant coefficient. Then again we will resubstitute the value of z in terms of log x. Now we will do one question so that we can easily get what the type of equation and how can we solve it. First of all, in that series we will do only homogeneous equation. So suppose that question is given x square y double dash 4xy dash 2y equal to 0. Now see, in this case the coefficient of y double dash is variable, simple x square. The coefficient of y dash is also variable 4x. So first of all, as we can see, we will write it down x square d square y by dx square, then 4x dy by dx plus 2y equal to 0. We will write down this equation in symbolic form. How can we write down x square d square plus 4x into d plus 2 into y. We have done all these things in our previous videos, how we have to write down symbolic form. And after that, what we will do again, what is the method? We will put x equal to e raised to power z, and we will put here x square theta square is equal to theta into theta minus 1. Then we will substitute x into theta, x into d equal to theta, and we will substitute these values here. So firstly there is x square d square, so theta, theta minus 1 plus, then it is 4 times theta plus 2, again it is a y that is equal to 0. As I told you already, when we are talking about d is operator d by dx, but if we are talking about theta, this is a d by dz. So we will simplify it. It is theta square minus theta plus 4 theta plus 2 y equal to 0. After that it is theta square plus 3 theta plus 2 y equal to 0. What we will do here, firstly we will write down auxiliary equation. So because its complete solution is just a complementary function. So firstly we will write an auxiliary equation, that is theta square plus 3 theta plus 2 equal to 0. As we have done in our previous lectures, how can we solve this type of equation? If in terms of theta square we have a d square, how can we solve? We will find its roots. So similarly we can write it down theta equal to m. So if I write down, I'll get here m square plus 3m plus 2 equal to 0. How can we make a factor? If you are able to make a factor, you can easily factorize it. If you are not able to make a factor, you can use a discriminant method to make the factor of this equation. So again we will make a factor, m square plus 2m plus m plus 2 equal to 0. So here m plus 2 plus 1 m plus 2 equal to 0. So m plus 2 and m plus 1, because m plus 2 is taken as a common, in bracket we will get m plus 1. So again we will get m equal to minus 2 and minus 1. There are two roots of this equation. So what is the complete solution? Complete solution of I is c1. Same, e raised to power minus 2. But now our function is in terms of z. So what we will take here? Z. Then c2 e raised to power minus z. Again we will resubstitute the value of z is equal to log x. So if we want to put here the value of log x, sorry, I'll just do here. If we will put a value of this term, so how can we solve it? To solve it, first of all, we will replace here, uh, y equal to, I'll just rub it so that I can write it down in a elaborated way. So if we want to see this, we will put here z is equals to log x, and again we will put minus z is equals to minus log x according to the value. Now see here. So we will take y is equal to c1e minus, it's a 2 times log x plus c2e minus log x. If we will do here c1e log x minus 2, c2e log x inverse. So again e and log, you will get here c1x minus 2, c2x raised to power minus 1. So it is c1x square plus c by x, it is a y. So this is the solution of our differential equation. In our next video we will do one more question based on this, and then we will start with non-homogeneous differential equation with the constant, sorry, with the variable coefficient. Thank you very much.